Alright, hello, my name is Chase. I'm the sole developer behind MONS Studios. Today I'm going to be talking about PathPro by MONS. PathPro is a pathfinding project that my goal was easy implementation into already existing projects, but also giving you the dynamic adjustability to make it more yours, and also give pathfinding a little more dynamics and interestingness. All right, so to begin with, you know the rules: Windows, Package Manager, My Assets, find it, bring it in. Here it is. Wow, incredible. So if we open it up, start with, I should say, I'm in URP. The project was built in URP. It does work in HDRP and SRP. You will notice if you open it up in HDRP or SRP, there are some leftover camera scripts that are added during URP, and those won't cause any error, so they'll just throw some alerts, but you can just get rid of that in those. And then if you just try to run one of these scenes right off the bat, you'll notice that you will have an error, and I'll cover how to fix that in 1 second, because there's one thing you need to do. So in Path Pro, you'll see 3 folders and 2 instruction guides. These are both the same things, but they give you detailed instructions on how to pretty much get everything if this video is not for you. Alright, we have another folder, we have a scenes folder, and we have a scripts folder. Go ahead and open up the scripts folder. We have a main scripts and another scripts. Go ahead and open up main scripts. These 3 scripts are your bread and butter. These are basically everything that you need to get the package running within your existing package or project already, hopefully. Everything else here is just to show you how things work, the dynamics of it, the different things you can do. Go in other scripts. We have a camera fly-in script, a delay enabler, and a maze generator. How fun. All right. We have a scene script with 5 different scenes. We're going to go through those, but first of all, we're going to go to other. So here we have our materials, and if you're using HDRP and SRP, you need to come into materials, and you know how to do it. Everybody's done it. You can do it here, or you can do it in the converter, but these need to be converted to whatever pipeline you're using. Otherwise, it's gonna freak out on you, and you're gonna have your magentas everywhere. So in our prefabs, we have a cheese, a rat, and an unwalkable. The cheese, just a regular object. It's just here because it's cheese, you know. You'll find out soon. The rat, so this one's actually important to an extent. This one's showing how one of those 3 scripts, the movement script, ties in with the whole system, and we'll go more into depth in that in a second. This is just a simple, basic cube that's an unwalkable object. What makes it unwalkable isn't the object being called that. So if we go inside of it, we'll see that it has a layer mask called unwalkable, and if you don't have that, you'll need to add that and mark and set that in here, unwalkable. And what that does is, since this is a grid-based system, when these objects that are marked as unwalkable are on those nodes, which are the squares of a grid, they are marked as unwalkable, and then the pathfinding algorithms will not utilize those squares. You'll see what I mean here in a second, hopefully. So after you've done your layer mask, we're going to go ahead and open up that first scene. And this is an object scene. I'm just going to go through it real simply. We have our ground, which is just a simple plane with a mesh renderer. And in here, we have some of those unwalkable objects with the unwalkable layer mask. And you see all I've done is just change some sizes, move them around. And you'll see why in a second. So right here is an empty game object, and this is holding 2 of those bread and butter scripts. These are the backbone. So we have our grid manager and our pathfinding manager. And our third script, our movement path pro, is in what would be your agent, your thing that you want to path find. So we'll start off with the grid script. So what this does is creating a 200 by 200 size grid with a node radius of 1. So that means each one of those squares on our checkerboard is 1 distance. And right now the cell height is just 1. We don't have any verticality, but I will show you that in another scene. Check walkability. So this is really interesting. So this is on a timer right here is what you see. And our grid, when we have those unwalkable objects move around per se in the scene, if we're checking that every frame or just constantly, it's going to really bog us down possibly. So what this does is every second it checks for those changes in the grid, and then the pathfinders will adjust based off of those. Right here is something really important. This will be marked blank on yours because you have not assigned your unwalkable layer mask yet, and this is something you need to do. Mandatory. So if you open up the Pathfinding Manager, you'll find there's nothing in here that you need to do, but there are some settings that you can play with. We have smoothing paths and curving paths. So what the curving does is basically it bevels the corners, and there's a certain resolution that it has and a certain bevel size. And if you play with this, you can have some interesting effects. I like keeping these around. I like keeping these low, but these together really straighten out the pathfinding. You'll see in a second, because there are gizmos within Unity editor that let you see it while it's running. So if you take a look at a rat, you're wondering, all right, why do we have 6 rats in this scene? That seems kind of crazy. Well, in our movement script, if we look, we have 6 different pathfinding algorithms. Now, A star is the GOAT. Weighted A star is like, I still prefer A star. Greedy is probably my least favorite. Dijkstra, I don't know if I'm saying that correctly, but this and I believe one of these two is actually what make A star. They're all just like combinations of each other, and they're really interesting. But I don't want to go in too depth about the algorithms, maybe in another video if that's something that you find interesting. But here's a way you can choose which algorithm to use. Different settings to play with, avoidance settings, and we'll talk about this in the different scenes when we narrow them down per scene. But here is our speed, and if you think about the agent and tying it to something you already have pre-existing in your game, there's several ways you can do it. You can either give it a movement script, or you can tie it directly to one of these cylinders, or you could tie it directly to the speed. It's really up to you and what your project consists of. And at the end of this video, or towards the end of this video, we'll actually just make one from scratch really quick. We'll make a little scene, and I'll show you how easy it is to do it right off the rip. So now we know that each one of our rats is running a different algorithm. And why is this? Why do we need all these ones? Well, you don't, but I wanted to give the developer more adjustability, more dynamics. And when you run it, it's really interesting, because it's almost like they have different levels of intelligence. And how the system really works well is each one has a target. So right now, like, each rat's target is the cheese. And since these unwalkable objects are within our grid, when we press play, we'll see all of our rats go around the unwalkable objects to the cheese. And you're like, well, I still don't understand how that's working. So we click on scene. This is where things start to make more sense. So these are the gizmos that are built into Unity Editor that lets you see cool things. So this is our grid, and these are our nodes within our grid. And if you see, as you can see, under the unwalkable objects, all the red, those are unwalkable nodes. And as you can tell, the different algorithms go around said unwalkable objects. But what's neat is, so I can take my cheese, I'll drag it out here, and they'll recalculate. You'll notice, oh, what, they're not running on their paths exactly. Well, that is where the smoothing and curving comes in. If you turn smoothing and curving back off, these will all follow their exact path. This guy's a funny one. He likes to take big, long, complicated paths. But actually, he pretty much just goes through the whole grid. But it's interesting because that algorithm led to a better one, and they all lead to better ones, and blah, 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 blah. But as we walk through our scenes here, so here's a maze scene. And they don't take this long to path find. I just added a little delay enabler because the maze generation can be a little wild sometimes. But as you can see here, based off of where the cheese is, what the grid is, different algorithms actually perform differently. But I would say A star is by far the leader, the top cheese rat eater. Well, I didn't mean for that to actually happen, but all right, let's go to the next scene. All right, in this scene, we're going to talk about verticality. And if you remember, in our grid script, we do have a cell height, and this will change the height of our different nodes. But in this scene, I actually haven't done that, and I like to trick the agents into pathfinding vertically for me. And you think, oh, how can I do that? Well, if we change the rigid bodies to non-kinematic, what you'll notice is what is marked as unwalkable at the grid's root base position, they'll still pathfind around that. So you can follow that all the way up and create an entire system just based around that and save a ton because you don't have all those excess nodes. And as you see, so we still just have our original nodes. But if we had multiple layers, then we're basically just 2 times our information each time. I mean, just too much stuff going on. But if we keep it down to just 1 layer of nodes, we can get verticality out of that still. It's really nice. All right, we have a little chase scene set up here. We have a cat and a mouse, both of which are each other's targets. But if you click on the mouse, you'll notice that the avoid boolean is true. So when the avoid boolean is true, the target then becomes what the agent is trying to avoid. So instead of going towards the cat, it's going to try to avoid the cat based off of its danger zone settings. So there are tooltips in here explaining to what these different settings mean. And these are just something that you're going to have to adjust yourself and play around with and do kind of your thing. But if we go ahead and play it, this took me probably one of the longest, and some of you might think that's silly, but I think it works great, and I really do like it because it's kind of picking a random point, but there's more to it than just that. But at the same time, where batches are low and frames are up, and we like that. So that's just one boolean, the click of a boolean, and you have a chase on your hands. All right, let's go ahead and check out the next scene. Don't worry about all that. So in this scene, we got a bunch of bobs, and we're back at it with the non-kinematic rigid bodies. So all of these bobs have something unique clicked on them that the other ones didn't, and that's the random roaming is clicked true. Now when this is true, all this other stuff is kind of voided out, and they just start going on their own little merry ways. And here you can change how far you want them to roam. But if we go ahead and click play, you see tons of roaming with very little problems. That's 50, I think. I actually wonder how many we can get going in there before that sucker starts. Let's try her out. Let's do 100, 150, 200. Let's try 200. I don't know why I sound like that. All right, let's go. There's all those non-kinematic rigid bodies that were just put on top of each other. But don't mind that. Don't mind them all raining on top of each other. They'll eventually fall off. Still hitting good. Still hitting good. And we have all of our gizmos on and everything. Gorgeous. Of course, you can turn off your lines and all that. This is just for visuals. All right, so as promised, we're gonna make a new little scene here and show you how quick and easy this can just be implemented into a project or one from scratch. New scene. Let's call it big toes in the pool. I know. Big toes in the pool. Oh, there's no pool and there's no toes. We better get something going on here. Make a 3D object. Let's make a plane. It's going to be our ground. Reset. Center that sucker up. Let's make it 25, 25. It looks real nice right there. It's a real nice floor. Gorgeous. We're going to go ahead and create a... who should we use? We'll use a cylinder. Alright, Mr. Cylinder Man. Make sure you put him one up so it looks real nice. Alright, what's your name gonna be? Tedley. Tedley the Tedler. Let's go ahead and get some names down here. Alright, Tedley. You are as bare bones as it comes. You, sir, deserve. Let's go to our main scripts here. So we'll go to scripts, main scripts, and movement. Tedley, you're getting a movement script. A star, good speed, good settings. We'll keep it. All right. Next, let's create an empty object. Reset it. That's just my own personal preference, but this is just an empty object you're going to use to hold some scripts. We're going to lock that, and that lets us drag multiple things into something at once easier. Unlock it. Click on it. Here it is. All right, so we need to set up our grid. Very important. We need to set our layer mask, unwalkable. That's our unwalkable layer mask that we've set. We'll make it 200 by 200. We'll leave it in the center. And we'll keep all the nodes and stuff that way. Gorgeous. Next we'll need to do, let's make a little wall here. Nice. Gorgeous. Whoa, excuse me. Nice big old wall. And old Tedley here, he said, what's behind the wall? Let's put something behind the wall for Tedley, shall we? Let's give him what's gonna be behind the wall? Tedley, he looks like he's a fiend for just some good old not bad stuff. Tedley, we really hope you can't find that, but I think he might. Let's give it a rack. See what happens here. We're going to have to go into our scene to see what's going on here. Oh no. None of our nodes got marked unwalkable. Why? Well, let's go ahead and check out our wall. Can you see what's wrong here? That's right. You didn't set it to unwalkable, dude. So let's go ahead and save. Hit play. Look at that. Around the wall to the black tar he goes. But for real, Tedley, we're going to have an intervention here soon. Alrighty, well, that about wraps it up. I think I've covered about all the bases here. I hope I haven't missed anything. But if you have any issues, feel free to reach out to my support, which you can find in the Unity Asset Store. Doses.